Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's DevOps.com webinar, brought to you by TechStrong. My name is Cody J. Brown, and I will be moderating today's session. We have an exciting presentation ahead of us, but before we begin, I have just a few housekeeping notes. Today's event is being recorded, so if you miss any or all of the discussion, it will be made available for you to rewatch. You'll receive an email after the webinar concludes with a link to access the on-demand. We want to hear from you, so please feel free to send in your questions at any time throughout the program by using the Q&A tab. We also encourage discussion by using the chat tab. Let us know your thoughts and comments, suggestions, or just say a quick hello. Finally, at the end of today's webinar, we will have a drawing for 4 $25 Amazon gift cards. Stick around to see if you are one of our 4 lucky winners. Let's go ahead and kick off our webinar today. Our topic is Accelerate Your Journey to Hybrid Cloud and Containerization. And joining me is Gary Evans, Customer Success Manager at Fujitsu, and Neeraj Arora, Consulting Architect and Global Strategic Alliances for Fujitsu. Gary and Neeraj, thank you so much for being here with us today. The floor is yours.
Excellent. Thanks, everyone, for giving us an opportunity to talk about your cloud journey to hybrid cloud and the role of containerization in that journey. We have put some few slides together to talk about the trends of hybrid cloud, the challenges of the hybrid cloud, and the role the containerization plays in that. And in the end, we have a bit of a short demo to show how some of these challenges can be resolved or can be overcome using the latest technologies and solutions available to us. We are coming to you from Fujitsu. So talking about hybrid cloud, what is a hybrid cloud? And this is a definition straight from National Institute of Standards and Technologies, which says hybrid cloud is a use of IT resources across a mixture of internal and external cloud services that incorporates some degree of workload portability. And workload portability is the key focus, orchestration and management across 2 or more environments. It essentially is the use of IT resources which are being used across internal and external services and provide the benefit of cloud, which includes flexibility, resiliency, scalability, and availability of your IT services. The key focus, from what we understand, is the consistency in management and oversight, applying the right securities and policies to the IT workloads, irrespective of wherever those IT workloads are running, whether it is in your private cloud or in the public cloud, different environments. Then the next question, which we typically get from the customers, is why hybrid cloud? Clearly, we have identified 3, but there are obviously more reasons for going hybrid cloud. From what we see, the 3 key important reasons for going hybrid cloud are increased control. And what we mean by that is the companies can customize the private end of their hybrid cloud model to their specific needs and adjust them according to as they seem fit, essentially providing an enterprise-centric control which is extended from their traditional on-premise environments to the cloud environments. The second reasons customers are looking for hybrid cloud is the increased agility and innovation. The ability to create a common computing architecture that can deliver a better reliability, optimized performance, and agility needed to meet the changing business needs is the key driver for going hybrid cloud. With easy access to cloud vendor services, customers can enable rapid experimentations with their new cloud-based services, both in the data analytics enabling them to have data-driven decision-making, as well as improve customer engagements. And finally, the third key important reason is the improved security and risk management. Hybrid IT services portfolio addresses the issues of multi-tenancy and security concerns within the cloud. Using a hybrid cloud-based propositions, customers or enterprises can choose dedicated servers, network devices that can isolate or restrict access to their IT infrastructure, and giving them the best of all the worlds, public cloud, private cloud, working together in any combination. Looking at the trends of hybrid cloud adoptions across the organization, there are a number of reports which have been published, and this one specifically from Cloud Native Computing Foundation has identified the use of hybrid cloud or multi-cloud is going to increase significantly, with almost 78% of the organizations adopting hybrid cloud in production. And so it's no longer an experimentation play. It's more of organizations adopting hybrid and multi-cloud for production use. The reasons the customers give is improved automation and maintenance and monitoring, almost 65%, ability to get access to the latest and the greatest infrastructure services, 47%, and all of this resulting in a faster time to market value from a business perspective is 27%. So clearly, the trend to hybrid cloud adoption is accelerating, and it is going to be a prevalent use case by the IT leaders. And one of the things which is driving the whole hybrid cloud adoption is this concept of containerization of applications. The study by Gartner predicts that 75% of the global organizations will be running some sort of a containerized applications. And when we talk about containerized applications, Kubernetes has become a de facto standard for orchestration and management of containerized environments. The Kubernetes provides benefits like shorter release cycles, so you have obvious benefit of software velocity, consistent operations, and portability. Because your software packages are containerized, it gives you the benefit of being able to deploy them in any environment, thus driving the adoption of hybrid cloud. Some of the trends which we see is almost 69% of the organizations have containerized more than 10% of their applications. So what we are trying to show through these trends is container adoption and running those container workloads on a Kubernetes is going to be one of the major IT environments as a source of hybrid cloud adoption. Having looked at all the benefits of hybrid cloud and what hybrid cloud is, people are starting, as they get onto the journey of hybrid cloud, they start to see some challenges with hybrid cloud because it's not all that straightforward and easy. So we have identified, we're going to talk about some of the challenges or impediments to hybrid cloud. And one of the topmost impediments is monitoring. The organizations need to be able to monitor, track, apply, and enforce their security and privacy policies on their workloads across the hybrid cloud environment. And those policies are based on the business requirements, and they have to be applied in a repeatable and automated way. And all of that requires some specific engineering effort. We talk about security, and especially some regulated industries like banking and healthcare have additional security requirements like PCI DSS or HIPAA or even NIST cybersecurity framework. This require visibility and oversight of use of cloud services to ensure compliance with these laws and regulatory requirements. And that requires an additional consideration when you're implementing hybrid cloud. One of the biggest impediments we see in hybrid cloud adoption is data gravity. As the organizations work with larger and larger data sets, moving the data around to various applications across different environments becomes challenging and expensive. And this is, in our opinion, one of the biggest impediments customers or organizations have to overcome to really take advantage of the full hybrid cloud. Workload transitions. What we mean by workload transitions is monolithic traditional application architectures make it harder to move the workloads between environments. So unless the customers or organizations have already started adopting transformation into containerized workloads, as I mentioned earlier, moving monolithic applications into a different cloud environments, it will always be harder. So this is again a summary of those challenges, which we believe, and we are going to talk about some solutions on how some of these challenges can be resolved through the technology enhancements and solutions which are available starting to show up. Now that we have looked at the benefits of hybrid cloud, the challenges of the hybrid cloud, let's look at what are the solutions to adopting hybrid cloud. So clearly, there are two different distinct ways to address hybrid cloud architectures. The one which has been predominantly used so far has been the traditional hybrid cloud approach, which we call it an infrastructure-focused approach. The traditional hybrid cloud architectures are based on connectivity solutions which are provided by the different cloud vendors, which includes some sort of a VPN or Express route services, which cloud vendors provide and extend their cloud instance or virtual private cloud instance to the customer's on-premise environments. The second approach, which is the modern hybrid cloud approach, is very much an application infrastructure focused approach, which focuses on the portability of apps running in the different environments. It's very much a decomposed, decentralized, microservices-based application approach, which are deployed as containers in the different environments. The smarts which are built into the application architectures, and that gives them the flexibility and support the distributed architecture across the different environments. And as we have talked about containerization, which is accelerating the adoption of hybrid cloud. So in summary, there are two distinct approaches to doing hybrid cloud adoption: the traditional cloud infrastructure focused approach or an application infrastructure focused approach. When we look at a modern approach, which is a application infrastructure focused approach, where the applications or your IT workloads are increasingly containerized and microservices based application architecture, based distributed system architecture, there are some additional control functions which needs to be taken into account before the customers or organizations can take a full advantage of hybrid cloud. And these additional control functions are visibility on traffic flows between the microservices. So the very nature of microservices is you have a distributed environment, all these microservices running in different containers, and the inter-service communication has to be enabled for achieving the outcome the business applications are trying to deliver. As the inter-service communication becomes important consideration, controlling and securing communication between these microservices becomes even more important and challenging. And this is specifically important from a security implementation perspective. You want to ensure that only authorized inter-service communications are allowed within your IT environment. The resiliency in case of microservices containers failing or microservices failing is another application architecture consideration which we need to think about. The immutable nature of container infrastructure gives you an ability to manage and restart your container workloads, but your application resiliency is equally important to be considered. The next additional control functions which we need to think about is the data management for stateful applications. The stateful application has a specific requirements for maintaining the state within their data sets, and to manage those stateful applications, you need to have some specific controls you need to apply in your microservices-based applications. And finally, a declarative way to define the network behavior, the node identity, and the traffic flow through policies is what is a mandatory, in our opinion, a way to deliver microservices-based application deployments in a hybrid cloud environment. When we look at container adoption and with the different options available to customers using either a cloud-based container orchestration, we see that there are some technical challenges, and organizations have to implement or have to take decisions to overcome these technical challenges. And these challenges include infrastructure supporting services between the providers, especially when you're looking at a traditional hybrid cloud architectures, are very fragmented and unique to each environment. And what we mean by that is you have an EKS, Amazon will have an Elastic Community Service, or an Azure, which has an Azure Community Service, AKS. Their ecosystem of those container environments will be different. And that can lead to an integration challenges as the workloads move across environments. The cloud native stack, as I mentioned, AKS or EKS, have several implementation differences. And what we mean by these implementation differences is the networking stack which they would have implemented for their Kubernetes ecosystem, or the storage management which they have implemented for their ecosystem is going to be different. This provides difficulty on having a different operational know-how and portability when you were looking at workload movements between the providers. With the constant innovation at the technology level, the IT leaders are constantly faced with the skills gap and the lack of technical know-how with the latest releases which they constantly do on the Kubernetes ecosystem, and ensuring that your production deployments are not constrained with this constant innovation in the technology is another consideration organizations would have to think about. The cloud native ecosystem continues to evolve rapidly with new projects, products, vendors, and business models coming up. The CNCF keeps adding up projects every 3 to 6 months. It makes it very difficult for technology innovation leaders to stay on top of it. So as an organization, if you have to stay on top of all these technologies, it becomes an increasing challenge. While Kubernetes has convincingly won the war over container orchestration, it has in its wake hundreds of open source projects which need to be considered as the organizations start to look at moving their IT workloads or applications onto a container-based environment management or a cloud-native ecosystem. In addition to all these multi-environment challenges, there are some additional issues. Some of these are maybe repetitive from the previous slide, but security and compliance, where you are running your Kubernetes workloads in a shared infrastructure, especially when you're looking at Kubernetes within the cloud providers, is another challenge. Many tools working together. We all know the DevOps environments or IT management environments customers have implemented includes multitude of tools, and making those tools work together across multiple environments is a challenge. Providing a constant checks of who's making configuration changes and how those configuration changes are applied across the different environments is another important challenge for customers, because any small mistake can lead to a major security gaps. Time to value. While hybrid cloud does give you time to value in terms of innovation, the steep learning curve due to the high complexity can impede that time to value realization. DevOps tools evaluation. As the DevOps tool sets change or differ from a cloud environment to cloud environment, and it may be totally different from your on-premise implementations, can also impede the time to value realization. And in case the customers are using ISV solutions, independent software vendor solutions, the license negotiations and procurement can add to that cost of delay. And finally, the cost of the lifecycle is another challenge customers would have to think about, where they may need specialist people to do the support and services across different cloud environments, different Kubernetes environments. You need a dedicated staff with specific skills, so that any challenges or issues you have at the infrastructure level can be resolved very quickly. So in summary, while hybrid cloud does give you the benefits, and we have looked at hybrid cloud architectures being infrastructure focused or application infrastructure focused, increasingly the application infrastructure focused solutions are predominant form of approach customers are adopting, but that is not that has its own inherent or challenges, both at the technical level as well as the environment level, which needs to be considered. Now that we have spoken about the hybrid cloud, benefit of the hybrid cloud and the challenges of the hybrid cloud, let's look at what are the different solutions which are available to us, which will allow us to design once and deploy anywhere, which is essentially what the hybrid cloud is. And for that, I'm going to hand it over to Gary to talk to us about some of these challenges, options. Over to you, Gary.
Great, thanks, Niraj. Hi everybody. My name's Gary Evans. I lead the Fujitsu Enterprise Postgres Center of Excellence Services team. We're a global team. Our focus is to ensure customers receive a great customer experience with the Fujitsu Enterprise Postgres product and services, as well as achieve great outcomes using our software for them. We work with customers throughout their journey with our products and services, providing best practices rather than reacting to problems once they occur. So today I'm going to be talking a little bit about some of the features of Fujitsu Enterprise Postgres and how they can help in addressing some of those challenges associated with hybrid cloud that Niraj talked about. So security around data, interoperability, data gravity, and so forth. So hopefully you can see the slide. So one of the standout findings of research articles on the hybrid cloud that I've read is the importance of on-premise infrastructure. Close to about 90% of organizations expect a significant on-premise environment for several years to come. And most of those organizations therefore feel that one of the most important considerations in developing a hybrid cloud strategy is the ability to integrate with that on-premise infrastructure or environments that they have. And I guess that explains why interoperability that Niraj talked about is one of the key challenges that the cloud service providers are addressing with their solutions today. This means the ability to move applications between on and off-premise environments and centrally manage those applications regardless of what environments they're deployed to. Fujitsu 2 addresses this key requirement, and organizations are able to deploy Fujitsu Enterprise database clusters to bare metal, virtual machines, private on-premise environments, or even virtual machines, private and public clouds that are off-premise, with the same set of enterprise features, open interfaces, allowing connectivity and integration from virtually anywhere across your hybrid cloud ecosystem. Being able to design once and deploy your enterprise database cluster to anywhere across your hybrid cloud environment is certainly one of the things that customers should be able to expect with technology available today. But what about the data that we store in those databases? With the amount of data that that organizations are collecting now, and the data in these databases getting so large, applications tend to gravitate towards them, and this causes the data to further increase in size. And then these databases are often found in the cloud in an effort to reduce latency by having the data closer to the applications that consume them. But a problem that can arise from that is that they reach a size where they're so big that it becomes challenging to be able to move that data from the current provider and therefore the applications and services that depend upon it or use it. And you can easily lose that agility and flexibility that you first moved to the cloud for, that Niraj talked about. And this is what's known as the data gravity problem. And yes, you could just stick with that one provider for your data, applications and services as well. But isn't this just another level of vendor lock-in? And what happens when services that meet your requirements better are available from another provider, or another service provider offers significantly better rates for the type of workload that you're running? How easy is it going to be for you to move that data and applications to somewhere else? So this is one of the reasons why many cloud hybrid strategies also incorporate a multi-cloud element to it. Gartner expects more than 65% of organizations are going to adopt a multi-cloud strategy for this reason as part of their hybrid strategy. And it makes even more important. It makes it even more important to have a hybrid cloud strategy that has a focus on your data and how that data can be moved between providers, how it can be accessed from different providers efficiently with low latency, and how can that data be secured. So Fujitsu Enterprise Postgres targeted the OpenShift container platform from Red Hat early in its development to support hybrid multi-cloud environments, as it allows a consistent implementation of the database system regardless of which cloud provider you wish to utilize at a particular point in time. You get the same security features, you can move data between them, not just via like a backup and restore, but you can also replicate across providers too if you're using something like logical replication, which you don't necessarily get with some of the data as a service implementations from many of the cloud providers out there. Generally, the approach of running small to medium databases in a cloud provider environment close to the applications or services that use them works well, as long as the size of those databases are managed appropriately. You know, it's quite easy to spin up a Fujitsu Enterprise Postgres cluster on another provider's platform that supports the OpenShift container platform, of course, and then moving data between deployments is simplified with the use of utilities that we provide with the product, like high-speed backup and recovery, which can assist, you know, with those larger databases that organizations tend to deal with today. There's utilities provided with it that allow you to leverage the platform storage layers, high-speed copy technology. So you can use that to replace conventional file-level processors with the ability to perform much larger scale operations in the terabyte area on domain. The other consideration when moving and storing data in the public cloud, as Niraj mentioned, is security. This is a common reason that we see databases staying on-premise with applications that access it then residing in the cloud. And that's fine. That works well. We just have to be very aware of latency and making sure that we manage it appropriately. So we see organizations looking into technologies like edge computing and edge storage, which can be expensive. So another approach is to look at how can we better secure that data in the public cloud. And excuse me, Niraj already talked about security in the public cloud, and it's pretty good. But what are some of the other things that we can do to better protect our data in the cloud? Protecting data at rest with transparent data encryption is one thing. Fujitsu Enterprise Postgres supports this across all of its implementations, whether it's for a x86 Linux-based virtual machine on-premise, an S390 Linux 1 version in the private cloud. We might want to go there because it can take advantage of the hardware security module on this. It's a FIPS compliant platform, and we can utilize that to store the master encryption key that we use to encrypt the data for our data at rest encryption. Or it could be a containerized version managed by the FEP operator running on a provider's public cloud. And a lot of that type of security, like transparent data encryption, is enabled by default. TDE is a feature that works at a table space level, thereby providing both flexibility and simplicity in securing the data, which is really what we want. Data masking is another feature which we can use to limit who sees sensitive data without impacting the original data set. Data is obscured or replaced with other values upon retrieval. While this type of feature is more commonly known for hiding data from users that don't qualify as having the required privileges, so GDPR requirements, things like that, it's also useful for creating databases with realistic data in development and test environments. And this is what we call offline mode. And it's great for reducing a lot of that rework and effort that developers often go to in creating test sets and suites for operation in those environments. As we know, that some of these environments don't always implement the same level of security control as what we see in production environments. The next area, or the third area I'd like to talk about that I think is important to meet hybrid cloud challenges is open standards. Next to common infrastructure compatibility, common application APIs and management interfaces are two of the highest rated objectives for those moving into a hybrid multi-cloud environment. I guess this isn't really surprising when application programming interfaces are the means by which applications and services can communicate, and they're a critical component in much of how we access and use services in the cloud as well as its automation. If applications, services, and data are to work seamlessly together across a hybrid cloud environment with 100% uptime, these APIs need to be consistent for the types of services they provide access to, and regardless of where those services actually reside. So applications and services need to be loosely coupled and have the ability to change and replace services, or to be able to do the types of rolling upgrades or updates that we now do in this environment without causing outages. The same is true of how we access data. Open interfaces, and by this I mean the use of a public standard, are key in allowing us to move data around, change the data source of a particular service or application, and query the information within that data source. Fujitsu Enterprise Postgres supports the same open interfaces regardless of where it resides. The ANSI SQL standards is a good example of a well-established open standard for querying relational data. Once vendors start moving away from these open standards, regardless of how well intended, we start creating barriers to being able to move data around and then change applications as we start finding ourselves more locked into a particular provider. Fujitsu Enterprise Postgres makes best efforts to support open standards, and Fujitsu migration recommendations are to utilize non-ANSI SQL features, which are available as add-ons only as a temporary measure on a journey to a full open standard compliance, making a more portable data set across your hybrid infrastructure. Support open standards facilitates the use of a much wider range of tools for centralized management as well, which was another key challenge that Niraj mentioned. So supporting these open standards in Fujitsu Enterprise Postgres allows management or centralized management of these clusters regardless of where they're located. So this applies to, the administration and monitoring tools as well. I mean, shouldn't the ability to be able to pick services that meet your needs also apply to the tools that we're using to perform the management of our services as well? Why be locked into a single vendor management tool? Okay, CI/CD, continual integration, continuous deployment, provides many benefits to an organization, and it plays a key role in the ability to design once and deploy many across a high availability infrastructure or architecture. This area has changed significantly over the last few years. Building high availability into applications now covers many facets, from building in the redundancy that's required, utilizing an architecture like microservices architecture that Niraj mentioned, containerization, automation of operational processes through the use of operators. They all play a key role in delivering the requirements of today's systems. The Fujitsu Enterprise Postgres operator and the associated FEP containers leverage the OpenShift container platform, providing those essential operational processes required for high availability in a database management system. The automated failover feature of FEP provides this capability in a matter of seconds, and combined with the connection manager feature, which provides improved connection management for client applications, means that failures on the server are managed almost transparently to end users. Other essential operational processes are also taken care of, like deployment of a new cluster, rolling upgrades, with a simplicity that we didn't see a number of years ago. And with this ability now built into CI, or continuous integration, continuous deployment, which I think is pretty well understood and utilized, CR, or continual response, is now becoming the focus of DevOps. Continuous response is also a very important part of DevOps and can be overlooked quite often. This is where deployed software is instrumented and monitored for changes in performance, workload type, operational activities, and so on, and corrective action or appropriate action is taken automatically. Operators make life easier for managing the complexity of applications. They have a rating system that lets you know the extent of their capability. So, for example, a level 1 operator manages installation of the software for you. So this is where you might hear the term single click install. Around the middle of the rating system, we've got level 3. We've got an operator with level 3 capability, which, when we're talking about database software, means that it can do things like automated failover, it can do backup and recovery. Then when we get to level 4 and 5, we're starting to talk about continuous response features. Level 5 is automatic pilot, or autopilot ability, they call it in the rating. It sounds great, doesn't it? Autonomous applications and all that type of thing. So the Fujitsu Enterprise Postgres version 13 operator is a level 5 operator. And one example of one of the level 5 capabilities that it has is the auto scale feature. The auto scale feature constantly measures the load on an available database, on the available database instances. And if this load is consistently high enough, the operator will automatically spin up additional replicated instances to handle that load. I believe the requirements to define profiles for different use cases for services as part of CI/CD is going to become less as we see more advanced versions of continuous response and operators making use of predictive analysis to make adjustments to the system before we even see the scenario for which the adjustments are made, resulting in services optimizing software they manage, or the services operator optimizing the software that they manage to an extent that pre-configuration may not even be a requirement. So that's a little bit of a summary of how I see Fujitsu Enterprise Postgres meeting some of the challenges around data in a hybrid multi-cloud environment. We've put together a bit of a demo, as Niraj mentioned, that shows how easy it is to deploy a Fujitsu Enterprise database cluster to firstly an on-premise virtual machine, and then we connect a simple application to it that might be running in the public cloud. which is very typical in a hybrid cloud situation, and then how easy we can deploy a couple of different database clusters to the public cloud, perhaps using two profiles that will be organizationally approved, and then we'll migrate data to that and connect our cloud application to one of them. Then we'll have a bit of a look at creating some artificial load on the database cluster, just to show how that level 5 operator CR feature, auto scaling, automatically adds some instances to handle that additional load. So let's look into that.
So for this short demo, we've created a number of YAML files, very simple ones representing organizationally approved deployments. We've got one here for creating a single instance of the Fujitsu Enterprise Postgres database to a bare metal or a VM. And then we've got another YAML file here for a high availability deployment, which installs as you can see, an arbitration server, which is used for automated failover, and then a primary and a secondary instance. And we've already actually gone ahead and deployed it. As see on the right hand side here, it's been deployed. And then once the database is deployed, we're just using Helm script here to connect deploy an application to the public cloud into OCP and connect to our database by specifying that connection string. Now we can go in and see that the application is working. So it's retrieving the data from our database okay, and enabling us to do a conversion. Now sometime later on, we might decide that we want to move the database to the public cloud to make it closer to our application. So this script here deploys two database clusters. If we have a look, you can see there's a FEP dev and a FEP prod. So by executing the script, we deploy two clusters. The main difference being that our development cluster just has one instance and there's no transparent data encryption configured on it. And then if we look at our other script that gets called, we'll see our production environment. It would deploy three instances out to, and there's a transparent data encryptions enabled with a passphrase. And then if we go in and have a look after that deployment that we've executed, you can see, looking at the YAML here of our development one, that we've only got, should be one instance deployed. Yep. And then if we go back and have a look at our production one, we should see three database instances deployed in our cluster, and transparent data encryption should be enabled and a passphrase should be set, but of course there's using a secret, so it's not visible there. So I sort of cut the video a little bit short there for times, but takes about 4 or 5 minutes to go through and deploy both those instances out to the public cloud. And then the next thing that we want to do is just reconnect our application that's running there to our newly deployed production instance that's running in the public cloud. And you can see we do that just by setting the connection string just there. So we execute that. And then we can, we're now using that OpenShift container platform database. Last thing I just wanted to demo quickly is here. If you look in the top left there, we're just generating some high load on our database instance. If you look down at the bottom left, we've got three clusters or three instances running, or three pods running down the bottom left there. Now down the bottom right, you'll see that as we've put that load on, we've got a warning in our alert system about a minute ago now, and you can see the load going up if we look at the metrics in the top right hand corner. I'll just zip ahead a little bit, so that's 2 minutes now, And we should see, after a little bit more time, if you keep an eye on the bottom left-hand corner, additional database instance getting created, and there it goes there. So after about 4 minutes of high load. Now just skip to head a little bit further. You can see about 7-8 minutes since the original one, and because the load is still very high, it's deployed a second one, so we've actually got 5 instances now running.
So I hope this particular webinar gave you some additional information to consider when you're looking for your hybrid cloud strategies and some of the challenges which you need to consider towards a successful adoption of hybrid cloud. And Gary has shared some of the specific features which we have in our Postgres to address the data gravity problems. Anything you would like to add, Gary?
Not really. Just on the slide here, Niraj, we've got a link where you can go if you've got any further questions and answers about the session. So if you click on there, you can provide your questions, and we'll get back to you as soon as possible, probably within 1 business day with a response. There's also a couple of URLs there that you can go to where you can get some more information about the Fujitsu Enterprise Postgres for Kubernetes, and where it's available in the Red Hat marketplace as well. So yeah, it's a pleasure to be here, and thanks for co-hosting this with me, Niraj.
No problem. I think
say goodbye.
Yeah, thank you. Thanks everyone.
Yeah.
Take care.
Okay, thank you.
So as Gary said, we have a link that if you have any questions you want to refer over to our speakers today, you can just go ahead and follow the link from the presentation, and they can get those answers for you as soon as possible. A quick reminder that today's session was recorded, so if you missed any or all of the presentation, or you'd just like to rewatch, it'll be made available for you. Following the webinar, you'll receive an email with a link to access the recording, and you can also find the recording living on the DevOps website. Just visit devops.com/webinars and look in the on-demand section. Now on to the 4 winners of our $25 gift card drawing. Our first winner is Tom H. Congratulations, Tom. Our second winner is Simon M. Congratulations, Simon. Our third gift card winner is Lewis M. Congratulations, Lewis. And our final gift card winner is Michelle R. Congratulations, Michelle, and to the other 3 of you for winning our $25 gift card drawing. Gary and Niraj, again, thank you again so much for taking the time to put together this program and demo. And I would also like to thank you, our audience, for being with us for the entirety of today's presentation. This is Cody J. Brown signing off. Have a great day, everybody.